Okay, let us see today the topic that is Z transform, and we will find out the Z transformation of one sequence. The sequence is of the type it is n plus 1 n plus 2 by 2 factorial a to the power n. इसका हमें Z transform निकालना है. So I will use the definition of the Z transform here, okay, to get the Z transformation of this sequence. So Z transformation of this quantity we have written here. Now use the definition. By using the definition, I can write down the quantity as summation n ranging from 0 to infinity. This will appear as it is here, multiplied to z to the power minus n. Is it okay? Now I will substitute the n is equal to 0, 1, 2, 3 and so on और summation को on करेंगे हम. तो अगर मैंने n is equal to 0 पुट अप किया तो यहाँ पे 0 पुट अप किया that is 1, यहाँ 0 पुट अप किया that is 2 upon 2 factorial a to the power 0 z to the power 0. ये पहला टर्म आ गया प्लस अब सेकंड टर्म के लिए आई पुट n is equal to 1. अगर मैंने 1 पुट अप किया यहाँ पे it is about 2 3 by 2 factorial a to the power 1 z to the power minus 1. 2 पुट अप किया तो 3 4 by 2 factorial a square z to the power minus 3. दिस इज थर्ड टर्म. वैसे भी 3 पुट अप किया तो आपको फोर्थ टर्म आ जाएगा. ओके, लाइकवाइज वी आर हैविंग अ वन सीरीज हियर. इसको थोड़ा सिंपलीफाई कर देते हैं. a to the power 0 1 होता है, z to the power 0 1 होता है. 2 factorial is 2, 2 get cancel. The complete equation, the complete term is reduced to a single 1 only. Then it is 2 get cancel, 3 is left, 3 into a by z is here, the second term. उसके बाद next it is 6 we are having, 2 get cancelled from here, 2 into 3 6 a by z square. Likewise we are having the next term that is 10 a by z cube plus goes so on. Now by using the binomial expansion, this series can be reduced to the form that is 1 minus a by z to the power minus 3. This is the important step. अभी कैसे आया हुआ है? We'll see that by the definition of by the binomial expansion, and provided this expansion is valid only for mod of a by z is less than 1. So we know the binomial expansion as here 1 plus x to the power n. The expansion is 1 plus nx plus n minus 1 by 2 factorial x square plus n minus 1 n minus 2 by 3 factorial x cube plus likewise so on. हम लेते हैं 1 minus a by z to the power minus 3. 1 minus a by z को मैं लिख सकता हूँ 1 plus minus a by z to the power minus 3. So that हम कंपेयर कर सकते हैं n is what minus 3 and x is what minus a by z. अब इसको by using the binomial expansion में expand करेंगे. तो expand किया तो it is what 1 plus n into x, n is minus 3, x is minus a by z plus n into n minus 1. So n is what minus 3, n minus 1 मतलब minus 3 minus 1 minus 4 upon 2 factorial. Then it is x square minus a by z square plus again n minus 1 n minus 2 by 3 factorial with x to the power 3, that is minus a by z to the power 3. Now simplify this quantity. This minus minus get plus 3a by z. This minus minus get plus, this is square, it is plus a by z square. 2 get cancel from here, 2 into 3 it is what 6. वैसे फिर ये आ जाएगा 10 a by z क्यूब. तो ये देखो वही सीरीज मिली हमको जो यहाँ पे थी. ओके, सो बाइनोमियल एक्सपांशन से हम इस सीरीज को सिंपलर फॉर्म में लिख सकते हैं 1 minus a by z to the power minus 3 provided mod of a by z is less than 1. अब mod of a by z less than 1 क्यों लिख रहे हैं? बिकॉज ये जो सीरीज है हमने एक्सपांड की बाय बाइनोमियल एक्सपांशन 1 plus x to the power minus 1, उसमें हमारा mod x होता है less than 1, तभी ये सीरीज एक्सपांशन वैलिड है. ओके, अदरवाइज नहीं. So we have reduced the series into the simpler form. Now we just simplify the quantity. I take the z here. This will be z minus a by z. Okay, इसका reciprocal कर देंगे because minus sign है यहाँ पे. 3 will be as it is. Then it is z upon z minus a cube. Now we know we have mod of a by z is less than 1. इसको हम कैसे लिख सकते हैं? Mod of a is less than, this z goes here, mod of a is less than mod z. So for that the z transformation of this quantity is nothing but z upon z minus a whole cube with the condition that mod a is less than mod z. Okay, so this way we find out the we apply the definition of z transformation and find out the z transformation of it is n plus 1 n plus 2 by 2 factorial a to the power n. Okay, thank you.